We'll see what exactly is chunking. We'll have a look at the introduction to chunking in this particular video. Along with that, we'll also see why chunking is required, and with that, we'll also see the different types of chunking that we have. So let's have an overview of what exactly chunking is. So if you remember, we had seen this RAG pipeline. Now in this particular pipeline, we had seen we have a huge knowledge base, and from that knowledge base, whatever is the data, we process it into documents. So specifically this chunking process is related to this particular section of processing, or I would say dividing the data into set of documents. So without any further delay, let's move on to the definition of chunking. So by the definition, chunking is the process of breaking down large documents into smaller, manageable pieces of chunks. As you know, we may have huge data. For every particular use case, we may have tons of data. We cannot directly feed that particular data into the RAG pipeline for retrieval purpose as well as for generation purpose. Even if we want to have a look at a particular thing from that huge amount of data, it's almost impossible for us to do that. So how can we expect it from machines? That is why to make their work easier, we use this chunking process. In this, what exactly we do? We break down the huge data that is actually present in the knowledge base in any particular format into smaller documents. And that smaller documents are nothing but the manageable pieces, and we call each smaller document that is created from this huge large documents is called as chunks. One single document is called as one chunk. So I hope the process of chunking is clear to you all. Now, this chunking process makes it efficient for retrieval as well as for generation purpose. And also note one thing, that whatever will be retrieved as a result with the help of this chunking process will be relevant information only. There are very less chances that we'll get wrong results. And therefore, this chunking process is very much useful when we talk about vast amount of data in the RAG pipeline. So I hope you must have got an overview of what exactly chunking is. Now we'll see the visual representation of how chunking works. Now, let's say we have a larger document. A larger document can be entire knowledge base. It can contain all the information that is relevant for your RAG pipeline for any particular use case. Now, if we try to feed this entire large document into the RAG pipeline, it will be very difficult for retrieval because this entire large document will be embedded into a vector, a single vector. That single vector will always be retrieved whenever any query is fired by the user. Now, since this entire larger document is retrieved in the form of results from the vector database, this entire vector for this particular large document will be fed in the large language model. Now, it will be very difficult for the large language model to parse through this entire larger document and find out the relevant results. So, to make the work easier, what we'll do, we'll simply use the chunking process. We'll divide this entire document into small chunks. Now here, we can divide this larger document into n number of chunks. We can have chunk 1, chunk 2, chunk n. The number of chunks can be decided by looking at a particular use case data. Don't worry about all that. We'll see in the upcoming videos how we can perform optimal chunking, as well as we'll also see that which chunking method will be suitable for various scenarios. For now, just understand that this larger documents is divided into n number of chunks. Now, each and every chunk will be then sent to the embedding model for creating the vectors of these. A separate vector will be created for chunk 1, separate vector will be created for chunk 2, and so on, instead of creating one single vector for the entire larger document. So I hope the visual representation of chunking is clear to you all. Now, we'll specifically look into why exactly we require chunking. So the very first point for which we require chunking is memory limitations. Yes, larger documents can exceed memory capacity. If we feed the entire larger document in the RAG pipeline, it will not be optimal at all because this larger document will require larger amount of memory for storage as well as for processing. If we use the method of chunking, it will break down the data into manageable sizes, which then will be easily stored as well as will be easily processed. So this memory limitation is one of the drawbacks because of which we require chunking. Next drawback because of which we require chunking is the processing efficiency. Smaller chunks are faster to process. Just imagine if you are given with entire big document and if I ask you to learn things from it, will it be manageable for you? No, right? If I give the same document in small pieces and if I make sure that every single piece is semantically complete, then obviously it will be very much simpler for you to learn that particular amount of information. Yes, the document remains the same, but the way through which I'm making you learn is different. So smaller chunks are always faster to process. It reduces the computational load. The third drawback because of which chunking is required is improved retrieval accuracy. If we use the process of chunking, the retrieval will focus only on the relevant sections. Once the perfect match is found, only that particular chunk will be retrieved as the final result and will be sent to the large language model for generation purpose. It will enhance the context-specific responses. And therefore, if a user asks a particular query, the user will get context specific responses only. There will be no rubbish as well as out of scope response will be given to the user. That is why chunking makes it very much helpful. The next drawback because of which chunking is required is that it simplifies the information management. It is easier to navigate and search as I already said that retrieval becomes faster because of chunking. It facilitates the quick access to specific data, and it becomes possible for us to focus on a particular specific area in detail. The fifth drawback because of which chunking is required is scalability. It allows handling of larger data sets. So even if the data gets larger and larger in amount, you don't have to worry about it because only the number of chunks will be increased. You don't have to scale your processing unit. It makes the system more robust and scalable. So yes, because of all these 5 points, we can say that yes, chunking is very much required. And if we explore it practically, you will understand why exactly it is very much helpful. So I hope the benefits of chunking is clear to you all. Now we'll have a look at the different types of chunking that we have. So generally we have 5 types of chunking. The very first type of chunking is fixed size chunking. In this we create chunks of fixed size. Next, we have recursive chunking. This is a very much interesting type of chunking in which we can create chunks with the help of separators and we can have many other things to explore in this. The next type of chunking is document specific chunking. In this, we create the chunks from the document by considering the document's structure. The next type of chunking is semantic chunking. In this, we create chunks by splitting a given text based on how similar the chunks are in meaning. Here, we consider the meaning of the chunk also, and that is why it is called as semantic chunking. It is very much powerful. Have a look at it in the upcoming videos. The next type of chunking is agentic chunking. Now, this is a very interesting type of chunking. In this, we use a large language model to determine the chunk size as well as the content that is based on the context. So all these powerful chunking strategies we are going to explore in the upcoming videos. And now I hope that you must have got an idea about what exactly chunking is, what are the different strategies that we can have in chunking, how powerful it is. Fixed size chunking. Now the name itself tells fixed size. The chunks that will be created will be of fixed size. Now let's have a look at the official definition of fixed size chunking. So by the definition, fixed size chunking is a method of splitting the text into chunks of a specified size. That means a fixed size that will be specified by the user, maintaining an overlap to ensure the continuity between the chunks. So a fixed size chunking is a method of splitting the entire document into chunks of specific size as well as it also has the functionality to keep the overlap. Now overlap is nothing but the repetition of certain number of characters or I would say certain number of words just to ensure that there is some continuity between the chunks that are getting created. Now don't worry about this if you are not getting it now. We'll be looking into one very great example through which everything will be clear. Now specifically for fixed size chunking, in this particular video we'll be using LangChain's functionality that is character text splitter. The character text splitter in LangChain achieves this by breaking the text strictly by the character count. So in this particular class itself, we have the functionality to add the count of the characters that we are going to specify for each and every chunk. Along with this, there are multiple other parameters. We are going to look into all that. So I hope you must have got a simple basic idea of what exactly fixed size chunking is. Now let's have a look at the working of fixed size chunking. Now as an input, we'll be providing the text, the entire text you want to split into chunks. That we will be providing as an input. That will be called as input text. Now specifically talking about the LangChain's class, the character text splitter, it has certain number of parameters. These parameters are chunk size, overlap, separator, if any. Now chunk size will define the size of every single chunk that we want. Overlap will define the total number of characters that we want to repeat from the previous chunk in the current chunk. And the separator parameter is used whenever in our document we have certain separators, for example, some special patterns or markdowns. Now, once we define these parameters, the process begins. Now, in this process, firstly, it starts with the first chunk of the specified size. That means it will iterate over the text, and whenever it encounters the limit where the chunk size is fulfilled, it will stop there and it will consider that many characters into the first chunk. Next, it will continue and it will move forward by the difference between the chunk size and overlap to create the next chunk. Now, once the first chunk is created, for the creation of the next chunk, the overlap of the number of characters that were defined earlier will also be considered from the previous chunk. Let's say two characters are there for overlap. That means two characters, that means the last two characters from the previous chunk will be used as the first two characters in the current chunk. And along with that, based on the chunk size, the next chunk will be created. And this process will go on until all the characters are iterated and all the chunks are created. It will repeat until the entire text is chunked. Now over here you can see clearly that the chunk size is playing an important role over here. If you define overlap, then it will also create an important role. Unless you explicitly define any separator, this won't be playing any role. But once you define separator, it will dominate the chunk size and overlap. So we'll look into these cases. So I hope the process is clear. And finally, as an output, you will get a series of text chunks maintaining the specified overlap. So basically, you will be getting chunks of fixed size along with the mentioned overlaps just to ensure the continuity or the semantics between the chunks. So I hope the working of the fixed size chunking is very much clear to you all. Now let's practically implement the fixed size chunking with the help of the character text splitter from LangChain. And let's see how this works in detail with an example. Let's implement practically the fixed size chunking. I'm here inside Google Colab, and the very first thing that we have to do is to install the library LangChain. So I'm running this command pip install LangChain, and along with LangChain, we'll also require LangChain community module. So let's run this particular command. You can see that the libraries has got installed successfully. Now, once we are done with this, we'll now have to import the needed modules and classes. So let's import from LangChain dot. Now we want to create chunks. So for that we have module something called as text splitter. Now from LangChain dot text splitter, we are going to import the simplest type of text splitter, that is character text splitter. Now, this character text splitter is specifically used to create fixed size chunks. You don't have to create your custom code for creating fixed size chunk. Yes, of course you can do that, but LangChain has provided the functionality of doing it automatically just by simply importing this and specifying the parameter details. Now that we have imported this character text splitter, let's execute this cell. Now let's create our custom splitter object. We'll call this CharacterTextSplitter class. And inside this, as I already mentioned, that it takes a list of parameters. The most important one is the chunk size. Now, the chunk size is defined based on the data that you are going to use. It depends on the format of the data that you have. For now, we are just going to consider one single statement as an input. That is why I'm going to define the chunk size as 10. That means every single chunk that will be created will contain 10 characters from the text that we are going to input into it. Next important parameter is chunk overlap. Now, the chunk overlap count depends on the chunk size. The ideal count of chunk overlap is around 10 to 20 percentage of what you have defined for your chunk size. Let's take 20 percentage of chunk overlap. So 20 percentage of 10 is nothing but 2. So let's keep the chunk overlap as 2. That means every single chunk, 2 characters will be repeated at the start from the previous chunk just to ensure the continuity between the chunks. As you already know that there is one more parameter called as separator. For now, let's not define it and let's check whether it works or not. Let's check, is there any need of defining the separator? So now let's execute this splitter. We have created our custom splitter. Now we'll be defining the text for which we have to create chunks. Now I have taken a very beautiful quote over here. Success isn't just about what you achieve, it's about how you inspire others to dream, learn, and grow along the way. Comment down if you agree with this. Now this is the text for which we are going to create chunks. So let's execute this particular cell. And now it's time to create the chunks by calling this particular splitter. So we'll define a variable called as chunks and we'll call our splitter. So our splitter class has some functions. We have create documents, split text. For now we are having a simple text string. So for that we are going to use split text function. In this we are going to simply specify the name of the variable in which we have the string for which we have to create chunks. So we'll define this and we'll execute it. Now our chunks are ready. Let's have a look at it. Oh, we have got the entire chunk in one single element of a list. But I have specified the chunk size as 10 and overlap as 2. According to this splitter, whatever result we have got, it's not correct. Now why it is not correct? Because we haven't specified the separator. And that is the reason behind it to behave abnormally. So let's define the parameter separator. And let's keep the separator as empty string. Because we don't have any special pattern in our sentence based on which we can create chunks. That is why I have kept the separator as empty string. Now let's execute this. Let's execute the chunks. Let's execute the other cells and let's see what we are getting now in the chunks. Now you can clearly see we are getting proper chunks according to what we have defined in the character text splitter. If you carefully observe at the first chunk, it has 10 characters. 1, 2, 3, 4, 5, 6, 7, space including 8, 9 and 10. So the first chunk is behaving properly according to what we have defined. Now if you look at the next chunk, here you can see the last 2 characters of the previous chunk, that is IS, has got repeated as the first 2 characters of this particular chunk. So the overlap functionality is also getting maintained over here. And again, the next chunk is having 10 characters. Now, one thing you can notice is that whenever at the extreme positions, you have spaces in the chunk. For example, if you look at the fourth chunk, what you, the total number of characters in this particular chunk are only 8, but we have defined it to be 10. It was supposed to be 10. Now, why it is 8? Because before the what, before the word what, there was a space in the sentence. If you look, here it is the space. And also after the word you, there is one space. By default, this character text splitter strips down the string that you have. So basically, instead of including the space at the first and the last, it will exclude that and it will keep only the character in the alphabet. So that is why here the size is only 8. Now, one more thing you can notice in these chunks is that the words are also getting splitted. Okay, if you look at this particular word, about, in the previous chunk, the first two characters were printed. There is no meaning of this first two characters in the word about, but still it was included as a substring in the previous chunk. So we can say that character text splitter doesn't take care of the completeness of the words. It will stop wherever the character count exceeds. Now let's play with this separator parameter also. Now we don't have any special pattern in this particular string. Let's try to put a special pattern in this particular string, which is 2 stars. Let's add one more pattern like this over here. So now what I want is, I want to split the entire string into chunks based on this 2-star patterns. So ideally there will be 3 chunks. One, this chunk, the another chunk will be this chunk, and the third chunk will be this chunk. So for that we have to define the separator, that is the 2-star, that is this particular special pattern that we have in our string. Now let's execute this again. And let's try to print our chunks. Now you can clearly see over here that we have got 3 chunks. That is, the first chunk is still this 2-star pattern. The second chunk is from this 2-star pattern to the next 2-star pattern, that is still dream world, and the remaining as the third chunk. So I hope the functionality of separator parameter is clear to you all. Now, apart from the split text functionality in the splitter object that we have defined from the character text splitter class, we have multiple other functionalities. For example, create documents, we have split documents. All these functionalities are used based on different scenarios. And we are going to look into those scenarios in the next video where I'll be explaining you recursive chunking strategy. So for now, I hope this fixed size chunking is clear to you all. Now that we have understood the fixed size chunking implementation, let's see when to use this fixed size chunking strategy. Now, the first mandatory reason to use fixed size chunking is that when you need to process large text into smaller and manageable pieces. And that is what is the meaning of chunking. Obviously, when your large document is not manageable, it's the best way to create chunks out of it so that it becomes manageable. The next and the most important reason is when you want to maintain some context between the chunks. If you remember, there is one parameter called as chunk overlap. Now that chunk overlap will maintain the continuity between the chunks. That means it is going to maintain the context between the chunks so that the semantics would not get lost. The third reason is that when we have to deal with character level operations like certain NLP tasks. So there are a lot of natural language processing tasks where we have to deal with all these scenarios at character level. So in all those operations, we'll have to use this chunking strategy. So I hope when to use fixed size chunking is clear to you all. Now let's move on to see why to use the fixed size chunking strategy. The first and the foremost reason is efficiency. Breaking text into smaller chunks can make processing faster. We have seen this particular thing in detail in the previous video, how it makes the processing faster instead of providing the entire large document as an input in the RAG pipeline. So this is the first reason, that is efficiency. The next reason is continuity. Overlapping the chunks helps to maintain the context between the segment. It will maintain the continuity. The next reason is flexibility, as this fixed size chunking is the easiest to implement and adapt to various text lengths and structure. So this is the most basic type of chunking strategy. Using this strategy, a lot of problems can be dealt. So I hope the entire thing is clear. We have seen the in and out of fixed size chunking. I hope every single explanation along with the implementation is crystal clear to you all. So let's have a look into the official definition of recursive chunking. The definition says that recursive chunking is a method of splitting the text into chunks that aims to preserve the context and meaning by considering the structure of the text. So here, it not only focuses on the size of each chunk, along with that, it focuses on preservation of the meaning by considering the structure of the text. Here, it gives the respect to the structure of the text. Now here it says that it preserves the context and meaning. This doesn't mean that it will take care that each and every chunk is semantically splitted. It doesn't mean like that. Here, the structure of every sentence will be preserved. Now, it doesn't mean that each and every chunk will be completely independent of the other chunks, like what we have in semantic chunking that we are going to look into upcoming video. Here, it only takes care of whatever chunk has got created that will be structure-wise complete. But it doesn't say that it will be semantically complete or independent of the other chunks. Don't worry if it is not clear. We'll be looking into ample examples through which everything will be clear. Now here in this video, we'll be specifically looking into the recursive character text splitter, which is one of the module in LangChain. Now how it works, it starts by splitting at the largest logical units, that is paragraphs. So basically, we'll be getting a text as an input. Now the text can be an entire text file. Now into that text file, there can be multiple paragraphs. So here starts by splitting at the largest logical units like paragraphs and then recursively splits into smaller units. For example, sentences or words if necessary. So basically it starts at the large scale and then as per the chunk size that is provided earlier for this particular splitter, it will split it recursively until it reaches some particular limit or I would say some particular threshold. And as I said, it will take care that structure-wise each and every chunk will be complete. So I hope you must have got a basic idea of what exactly recursive chunking is. Now we'll be looking into the working of recursive chunking. So at the start, it will take a text input, the entire text that you want to split. Now once the input is taken, now after that we have to define our splitter with the parameters. Now here we already have seen these parameters in the previous video for fixed size chunking, wherein we have seen the character text splitter module from LangChain. Here also we have to define chunk size, overlap, and separators. We know that chunk size defines the size that every chunk has to follow. How many characters a particular chunk should have is defined by chunk size. Then overlap takes care of the continuity between the chunks. Basically, some last characters from the previous chunk will get repeated as some first characters in the current chunk. So this is taken care by the overlap. Next, we have separators, which is again an optional parameter. Here, we can define some special patterns that our input might contain, on the basis of which it will create chunks. It will split it on the basis of the special pattern that we provide as a separator. Now, once our splitter is defined as per the parameters, it will now start the process at the backend. So how the process starts? It starts by splitting the text at the largest unit, that is paragraphs. So it will take the entire file as an input. It will check for the paragraphs. It will first split on the basis of paragraph. Then it will look for the chunk size. Obviously, if the chunk size that was defined is lesser than the paragraph that was considered at that particular moment, it will then recursively split it into smaller units. For example, sentences or words. So if the chunk size based on the paragraphs is too large, then it will recursively split it into smaller units. Now this process will continue until it reaches to a particular size which will match the chunk size. It may not match the exact size as that of the chunk size, but yes, it will be approximately same. But it won't exceed the specified chunk size. It can be equal or lesser than that, but it won't exceed the specified chunk size. And of course, if the overlap is defined, it will be maintaining that too. Now you must be wondering that what exactly is the difference between fixed size chunking and recursive chunking. It looks somewhat same. Then what is the difference? Don't worry about that. Once we will look into the implementation of it, I will show you the exact difference between both of them. For now, I hope the working of recursive chunking is crystal clear to you all. Now let's implement this recursive chunking with the help of the recursive character text splitter from LangChain. This is going to clear all your doubts. Now let's implement recursive chunking. Now you remember in the previous video we have seen these things. Here we have used the character text splitter method. We have defined our custom splitter, and in this we have kept the chunk size as 10, chunk overlap as 2, and separator as empty first. And then we intentionally defined some separator pattern through which we have seen the usage of separator. Also, we have taken this particular text as an input and we divided this into chunks like this. I hope this was clear to you all. We also seen some observations that each and every chunk was almost having the same size, that is the total number of characters 10, which was the chunk size. We also have seen that when the chunk was getting created, it didn't take care of the completeness of the word. If at the middle of any word the chunk size was getting fulfilled, it stopped there and moved the other characters in the next chunk, something like this. Here you can see the word isn't was a complete word, but in the first chunk we couldn't see that completeness of the word isn't. Here the word was also getting splitted. So that were some of the observations that we found out for the character text splitter, or I would say the fixed size chunking strategy. Now let's implement the recursive chunking strategy. So for that, I'm going to import the recursive character text splitter from LangChain.TextSplitter. Now for installing LangChain, you should run this command pip install LangChain. Along with that, I also have installed LangChain-community. After this, you can simply run this particular cell. Now using the recursive character text splitter, we'll define our custom splitter. So let's simply take the same code that we already have defined for the character text splitter. Here we simply define the custom splitter along with the required parameters. So let's simply do that for the recursive character text splitter also. So under the recursive character text splitter, we'll define the chunk size to be 10, the chunk overlap to be 2. That means the last two characters from the previous chunk will be repeated as the first two characters in the current chunk. Now here under recursive character text splitter, we have a different name for the parameter separator, and that is nothing but separators. We have to add an S, and here the separators takes a list. Here we can define the list of patterns through which we have to split the text that we have provided as an input. But for now, let's keep the separators empty. So that is why I have defined an empty list over here. Now let's simply execute this particular cell and our custom splitter will be ready. Now once the splitter is ready, we can simply create chunks. We'll call the split text function from this splitter object and we'll simply split the text. That is our input. So we'll take the same input that we had earlier, that is this particular string. Let's remove the special pattern which we intentionally inserted in the earlier video, just to make you understand how the separators works. So the text is success isn't just about what you achieve, it's about how you inspire others to dream, learn, and grow along the way. We'll take the same input and we'll pass it in this particular function. Once we execute this particular cell, our chunks will be ready. Now let's check how our chunks looks like. And here we have got our chunks. So here you can see each and every chunk is taking care of the chunk size. Along with that, it also takes care of the chunk overlap. Now you must be wondering that why the first chunk is not having 10 characters inside it. Here you can see 1, 2, 3, 4, 5, 6, 7. Only 7 characters are present in the very first chunk. Now let me tell you the reason. After this success word, that is after the 7 characters, we have a space. That becomes our 8th character. And after this 8th character, we have this particular word, that is isn't. Now this isn't word is itself a complete word. Recursive character text splitter makes sure that the completeness of the word is not compromised. If it was made in a mechanism to break the words, then it would have provided this particular substring as the first chunk. which the character text splitter did. You can see here that the first chunk contains the word success and is. Here is nothing but a substring of the word isn't. It didn't take care of the completeness of the word, whether it becomes meaningless or not. It doesn't care about it. It will break and it will break the words and it will put it into chunks just to fulfill the chunk size. But in case of recursive character text splitter, it takes care of the structure of the words. It won't break it just to fulfill the chunk size. So that is why the first chunk is not having the chunk size as 10. Now let's focus on the chunk overlap. Why the first two chunks are not following chunk overlap mechanism. Now according to the chunk overlap mechanism, the last two characters S and S should have got repeated as the first two characters in the next chunk. But this didn't happen because there is no meaning of the word substring SS. Here, because our chunk overlap is very small, it will require to break the word to get the substring SS as the first two characters in the next chunk. But according to the rule of recursive character text splitter, it looks for the completeness of the word. It won't break the word just to fulfill the parameter list that we have defined. And that is why there is no repetition of the last two characters in the next chunk. Now, recursive character text splitter won't work good in case when you have a very small chunk overlap or a very small chunk size. You will get to know its results when you will increase the chunk size or the chunk overlap. Let's define the chunk size to be 100 and chunk overlap to be 20. And let's now run these cells. So now here you can see that we have got two chunks. The first chunk is this, which almost fulfills the chunk size that is defined 100. And the remaining text is put into the next chunk. But here you can see, according to the chunk overlap, 20 characters. That is, you can see here, dream, learn, and. Dream, learn, and. The last three words are repeated in the next chunk. So you can clearly see that chunk overlap also works in recursive character text splitter. Here, it works intelligently. It won't break the word because it will end up with a substring which won't be having any meaning. There is no meaning of it. And that is how recursive character text splitter works. Now here you can observe that whatever chunks that we have got is in the form of a list. This particular list doesn't contain any information about the origin of from where this particular chunk has got created or what is the location of this particular chunk in the actual knowledge base. Here we only have the content present inside that particular chunk. Now there is a document object present in LangChain, which is a ready-made object. You don't have to customly create it. That particular document object will contain the page content, which is nothing but the actual content that you want to store in the chunk, as well as along with that, it will also contain a metadata parameter which will store the origin of that particular chunk. By default, it will store the file name that you are providing as an input. That means from where file this particular content has got inserted as in the chunk. Now, for now, we just have this particular variable text. In this particular variable only, we have defined this particular content. Now, first, let me tell you how this document object get, gets created with the help of the create document function. Now here, since we have only provided a variable in which we have defined the content, we won't be getting any metadata. Let me show you that. So we have something called as create documents function present inside the splitter that we have created, and in that we'll provide the text, which is this particular text. Now there is a condition that we cannot simply provide this particular text as it is because this is in the form of string. We have to provide it in the form of list because here it thinks that the user will provide multiple such strings. So that is why here you have to provide the string, or I would say the text enclosed inside square bracket. That means inside list. Now let's execute this particular cells and let's see how the chunks are getting created. Now you can see over here we have got the same two chunks, but this time we have got our chunk in the form of document object. Each and every chunk is a document object. Inside this document object, you can clearly see that we have page content, which contains the actual content present inside our text. And apart from page content, we don't have any other parameter over here in the document object. Why? Because we only provided the text as a simple string. So there will be no metadata stored for this particular string. Now let me show you how this create document function can be very much useful because of the metadata parameter in this document object. Now I have simply created a text file called as t.txt, and inside this particular file I have simply pasted the same content that we stored inside the variable text. Now what we'll do is we'll simply load this particular t.txt file and then we'll create chunks from it. Now inside LangChain, we have multiple document loaders. We can access that from this document loaders module. Now since we have to import a simple text file, we'll simply import the text loader from LangChain. Now this text loader will load the file that we have. We have to just provide the name of that particular file. First, we'll create an object of this particular text loader class. So let's create that. Let me write loader equals text loader, and inside this we just have to pass on the name of our file, or I would say the path to our file, that is t.txt. And then we simply load this particular loader object and we'll store it inside a variable called as document. Now this will create document of whatever text file we have provided. So let's execute this cell, and here if I show you what exactly is present inside this document variable, you can clearly see that our content in the text file has now got converted into a document object which has page content, and apart from this it also has the metadata, that is source, from where that particular page content has got retrieved. Now I think we won't be able to see the entire document object. Let me show you by simply pasting it here. Okay, now you can clearly see that it also has a metadata parameter which contains a dictionary which stores the source as the key, and the value contains the actual file name, or I would say the path to that particular file from where this particular page content has got retrieved. Now this metadata is going to be very much useful whenever you are dealing with a large knowledge base. Whenever you have to find out what exactly is the root cause of the error that you have got in the retrieval process, you can simply use this particular metadata variable to check what exactly is the root cause. Now, once you got your document ready, you can simply create chunks out of it. Now, the custom splitter that we already have created will use the same one, and instead of using the create documents function, we can simply use the split documents function because our document has already got created. You can see this is already in the form of document object. So we'll use this split documents function. Inside this, we'll simply pass on the document. Now we are not supposed to pass the document in a list format because already we have this in a list format. If you carefully look, here we have it in list format. So there is no need to include this in square bracket. Just while creating the documents from a simple string, it's mandatory to include it in a square bracket. Now let's execute this and let's see the chunks. Okay, so here you can see the chunks has got created, the same chunks we have got, but this time we have got each chunk in the form of document object. And along with that, it also has the metadata, that is the source from which file this particular content has got retrieved, that is t.txt. Now, since we have only one file here, that is why in both the chunks we have got the source as t.txt. But whenever we deal with multiple files, at that time this becomes very much useful. So I hope the recursive chunking strategy is crystal clear to you all. Now let's see when to use this recursive chunking strategy. So first, when we deal with text where maintaining the context and the meaning is very much crucial. As we already have seen, the recursive chunking not only splits the text based on the chunk size, but it will also take care of the completeness of the words that are present inside our context. It won't create a meaningless chunk. Next, when splitting the large documents or articles. Yes, of course, recursive chunking is very much useful whenever we are dealing with large amount of documents or I would say knowledge bases. For natural language processing tasks that require meaningful text segments. As already discussed, it creates meaningful text. But along with this, note one thing, it won't create semantic chunks. Here, whatever chunks has got created, it will be meaningful, but it doesn't mean that every single chunk will be independent of each other. So I hope when to use recursive chunking strategy is clear to you all. Now let's see why to use the recursive chunking strategy. First, for context preservation. It ensures chunks maintain logical meaning and structure. The structure completeness of the chunk is one of the special feature of recursive chunking. So it preserves the context. Next, flexibility. It adapts to various text structures and sizes. Whatever is the type of your text, or I would say whatever is the type or size of your input, it is very much flexible to all. Next is the improved readability. It produces more readable and coherent chunks compared to strict character splitting. So I hope the in and out of recursive chunking strategy is clear to you all. Of semantic chunking. This is the most interesting type of chunking strategy. Without further delay, let's dive into semantic chunking strategy. First, let's have a look at the official definition of semantic chunking. And here it is. Semantic chunking is a method of splitting the text based on the meaning and context. It ensures that each chunk is semantically coherent unit. Here, we do not use any strategy which will divide the chunks into fixed sizes or with fixed overlaps. Here, the chunks are created based on meaning. Let's say we have a text file which contains 5 paragraphs. The first 3 paragraphs are talking about one particular topic, and the last 2 paragraphs are talking about another particular topic. So, with semantic chunking, there will be two chunks created out of the text file. First 3 paragraphs will be a part of the first chunk, and the last 2 paragraphs will be a part of the next chunk. Here, there would be no fixed size. Even there are no separators involved in this particular type of chunking. Here, every single chunk will be ideally independent of the another chunks because all the information that is relevant to a particular topic will be present in a single chunk. So, I hope by the definition, you might have got a basic idea of what exactly semantic chunking is. Now, this particular method uses natural language processing techniques to understand the text and split it at logical boundaries such as sentences, phrases, or even topics. Now, as I already said, that here we are not going to set a particular boundary for creating chunks, for example, fixed size boundaries. So that is why here we use some techniques from NLP to create semantic chunks. So that was just a simple overview of semantic chunking. Now let's move on to the working of semantic chunking strategy. Do you want to check out this attractive funny memes? Then what are you waiting for? These are just a glimpse of the memes that I've created on my Instagram page. You can find the link to my Instagram handle in the description box. Please visit the link and do watch all these interesting funny memes. These are not just memes. These memes and reels contains technical information. Here I try to relate memes with the technological concepts. So please do appreciate that by watching all those. And if you love it, please hit the follow button. How it works. So let's have a look at the working. First, we need to apply the sentence tokenization to split the text into sentences. Now, obviously, in a particular text file, there might be a lot of information. Initially, we'll have to create some custom chunks from which we can then create the actual semantic chunks. So for creating the custom chunks, we can use this sentence tokenization. We can split the entire text file based on sentences. That means one single chunk will contain a single sentence. Now, it's not mandatory to use sentence tokenization. We can also split the entire text into paragraphs also. Even we can split it into couple of sentences. We can set the boundaries. Now, note one thing, this is the initial stage of chunking. Here we just create custom chunks so that we can apply the NLP techniques on these custom chunks so that we can get the semantic chunks. Now, once the sentences, or I would say the initial chunks are created, then we can simply analyze the meaning and context of each and every sentence. Here we are simply talking about one single sentence, but as I said, that we can also apply this technique to split it into paragraphs also. Now, here we analyze the meaning and context of each sentence. Now, this can be done with the help of embeddings. Now, there are a lot of open source as well as paid embedding models available. You can define your own custom model also. So in short, we have to create embeddings of every single sentence and then we have to analyze the meaning and context of each sentence so that we can group them afterwards. Now, once we analyze the meaning and context of each sentence, we can simply group the sentences or phrases that belong together based on their semantics. So let's say we have three sentences. We create embeddings of all the three sentences individually. Then what we'll do, we'll simply analyze the meaning and context. This means that we are going to find out the similarity between these sentences. We'll group those sentences which has the highest similarity score. Let's say the sentence 1 and sentence 2 are having the highest similarity score and sentence 2 and sentence 3 are having the lowest similarity score. Then we can simply group sentence 1 and 2 and create one chunk of it. And since sentence 3 is alone, we can create a single chunk of sentence 3. So this is how we group sentences or phrases that belong together based on their semantics. The speciality of semantic chunking is that it ensures that each and every chunk is coherent unit of meaning. So in short, we can say that each chunk will be a complete chunk. So I hope the working of semantic chunking is clear to you all. Now let's have a look at the implementation of semantic chunking strategy. Now let's see semantic chunking implementation. Now over here, let's consider a simple paragraph. Now this is a sample paragraph that I have taken. This contains some text related to large language models. So here we are going to create chunks out of it and those chunks will be created with the help of semantic chunking strategy. Now according to the algorithm, the very first step is to do sentence tokenization. Now, I already said you that as per the use case, if your data size is actually large, then you can also do paragraph tokenization or you can create custom chunks of some number of sentences initially. But here our data is very much small, so I'll be doing sentence tokenization. So for that, I'll be splitting this entire text based on sentence initially. Now for doing that, I can use split method. Otherwise, I can use regular expressions. Here in this particular video, I'll be using regular expressions. So for doing that, I'll be defining a function which is named as split para to sentences. And this particular function will take the paragraph. What this is going to do, it is simply going to split the entire paragraph based on sentences. So sentences equals re.split, and here I'm going to define the expression. Now for regular expression we have the re library in Python, so we'll simply import that, and inside this split function we are going to define the pattern. So here we are going to split the sentences based on full stop. So let's write the expression for that. So this is the expression, and the split method also takes second parameter, which is nothing but the paragraph that we want to split. Now this is going to return list, which will contain sentences present inside this paragraph and it will store it in the variable sentences. Now I'll simply return the variable sentences. Now let's execute this and let's check whether we are actually getting sentences out of this paragraph. So let's pass the para variable in which we have stored our paragraphs. Now let's execute this and let's see the output. So over here you can see that we are getting list of sentences. These sentences are splitted based on full stop. Now as per the algorithm, we are done with the very first step. Now let's move on to the next step. And the next step is to analyze the context of each and every sentence, which means here we are going to convert every single sentence into its vector embeddings with the help of an embedding model. Now, specifically in this particular video, we'll be using Hugging Face embeddings. So we have a method called as Hugging Face embeddings from LangChain. So we'll import that from LangChain dot embeddings. We'll import Hugging Face embeddings. So this is the method. We'll define our embeddings in the variable named embeddings. Now, since we are using Hugging Face embeddings method, this particular method takes in model name that we have to give. Now, there might be tons of models available for performing embedding operation on Hugging Face. We have to choose one wisely for our use case. For now, I have chosen BAAI DG Large. You can choose any embedding model from Hugging Face website. You just have to put the name of that particular model here. Now let's execute this particular cell. Now over here you can see we have got a dependency error. We have to install sentence transformer Python package. So for that we'll simply execute this particular command, that is pip install sentence hyphen transformers. This will simply install the sentence transformer package for us. Now you can see that the sentence transformer package has got successfully installed. Now let's execute the same code again in a new cell and let's see whether it works or not. So let's execute this. Now you can see our model is getting loaded in embeddings variable. This will take some time. And here you can see our model has got loaded. So basically we have our embedding model in the variable embeddings. We can use the embed query function to create vector embeddings of a particular query. Now in this function, we just have to pass on the query that we want to embed. So let's say I write this, I love Gen AI, and let's execute this. So here you can see it has created a vector of this particular query. This is how we can create embeddings with the help of any model. Now, if we carefully look that this is in the form of a list, let's try to check the length of this particular vector. Now the length here represents that for each query, the model that we have used, that is BAAI BG large, it creates 1024 dimensions of every single query. Now that we have gained ample idea about the embeddings, now let's try to create our custom function, which will create semantic chunks for that particular paragraph that we have taken as an input. So let's define the function. So let's name the function as create semantic chunks. So this particular function will take the sentence list. Now since we have our embedding model ready, we can simply create sentence embeddings for each and every sentences. So I'll use list comprehension for sentence in sentences. What I'll do is I'll simply use this particular embeddings.embed query function and I'll simply create embeddings of every single sentence one at a time. and the embeddings of all the sentences will be stored in a list. Now, since we are going to perform some operations on this particular vector embeddings, just to make things easy, we are going to convert this particular vectors in a 2D NumPy array. 2D NumPy array are always the best to perform operations. So for that, we are going to first convert this particular embeddings into NumPy.array. And for that, we are going to import the NumPy module and we are going to give it an alias as np. So this np.array will convert this particular embedding vectors into an array, and once it is done, we are going to reshape it into 2 dimensions. We can do this with the help of the dot reshape function, and we can simply pass this parameters 1, comma minus 1. This will convert it into 2D NumPy array. And obviously, we are now going to store all the vector embeddings in a list. Now let's define a list which will store the semantic chunks. Now how our approach will be, we'll simply iterate over all the sentence embeddings. We'll find out the similarity of the first sentence with the second sentence. If the similarity score is greater than 0.5, then we'll combine them. Then we'll club sentence 1 and sentence 2 into one single chunk. Then we'll move on to sentence 2 and sentence 3. If the similarity score between sentence 2 and sentence 3 is greater than 0.5, then obviously we'll club it into chunk 1, which contains sentence 1 and sentence 2 already. And if the similarity score between the consecutive two sentences is lesser than 0.5, then in that case, we are going to separate them into different chunks. So for that, I'm going to define a for loop. For I in range will iterate over the number of sentences. Here, we can get the number of sentences with the help of the length function. And inside this, we'll simply pass on the sentences variable, which contains a list of all the sentences. Now, initially, obviously, we'll have to create one chunk which will contain the first sentence. So for that, what I'll do is, if the counter, that is I equals 0, I'll simply write semantic chunks dot append sentences of I. That means the very first sentence in this particular case, since I is 0. So once the first sentence is encountered, it will be a part of the very first chunk in the list. Now, if the counter is not 0, that means if it is not the very first sentence that we are iterating on, then in that case, it should go in the else condition. And when it goes in the else condition, we will have to compute the similarity score between the current statement with the previous statement. Now we'll simply define similarity variable which will contain the similarities between the current sentence and the previous sentence. Now for computing the similarity score, we are going to import the cosine similarity module from sklearn dot metrics dot pairwise. From this, we are going to import the cosine similarity. Now, what this cosine similarity does, it takes two parameters, that is, the first sentence and the second sentence, and then it will compute the similarity score between these two. Now, here in our case, we have our sentence embeddings stored in the variable sen embeddings. This contains the embeddings of all the sentences in a list format. So we'll use the variable, and from this variable, we want two consecutive sentences. Now here, we'll simply write I minus 1 because I minus 1 represents the previous statement. And we will write the second parameter as sen embeddings of I. That means the current statement. So this becomes two consecutive statements. This cosine similarity will compute the similarity score between these two consecutive statements, and it will store it in the variable similarity. Once the similarity scores are taken, we'll simply now create chunks by defining some conditions. If the similarity score is greater than 0.5, So if it is greater than 0.5, that means the two sentences are similar. Now if they are similar, that means we'll write semantic chunks of -1. Now why I'm writing -1? Because whenever the similarity score is higher, we are going to append the current sentence in the last chunk that we have already created. That is why I have written -1 over here. Dot append the current sentence, which is stored in the variable sentences, and the index is I, that is the current index. Now note one thing, the similarity score is present at the first index of the first index in the similarity variable. So you can just imagine this is a list wherein the similarity score is present in the list which is present at the first index. And from that list again, at the very first index, we have our similarity score. So that is why I have defined similarity of 0 of 0. Now, if the similarity score is greater than 0.5, we have handled that particular scenario. But if it is not, then in that particular case, it will go in the else statement. And in the else statement, we can simply write that semantic underscore chunks dot append sentences of I. Now here we are going to append the sentence as a new chunk. That is why we are going to include it in a list. So I hope you are understanding that our semantic chunks will be a list of lists. Each list in this particular list will be one single chunk. It will contain some sentences. As per this particular algorithm, if the similarity score between two consecutive sentences is greater than 0.5, then in that case, whichever is the current chunk that is present in that particular semantic chunks, in that particular list only we are going to append this particular current sentence. But if the two consecutive sentences are not similar, then in that case we are going to simply create a new chunk in this particular semantic chunks, and the very first statement will be the current sentence in that particular new chunk. So I hope this particular simple logic is clear to you all. And finally, we are going to return the semantic chunks. So we are now done with this particular function definition. Now it's time to test this particular function. So let's execute this first. And now since we already have created sentences, let me show you that. Here it is. But we haven't stored it in a variable yet. So let's simply copy this and again paste it in the new cell, and let's store it in a variable named sentences. Basically, this will split it into sentences. So the paragraph is now split it into sentences, and in the sentences variable, we have all the sentences. You can see. Now what we'll do is we'll simply pass this particular variable in this particular function named create semantic chunks. Let's pass the sentences inside it, and let's check what happens. Okay, so we have got an error. It says that string object has no attribute append, and the error has got arise in this particular situation where it comes under this if statement. Now here, if we carefully look, our semantic chunks is a list, and the semantic chunks list contains again list. So at the time of creating the very first chunk, where when I was actually 0, what we had done, semantic chunks dot append sentences of I. So basically here in this particular semantic chunks, instead of creating a new list and then appending the first statement in that particular new list, we have directly appended the first sentence in the semantic chunks list. So we should not do like that. We'll have to enclose this particular sentences of I in a list, because this is the first sentence in the first chunk. And I think this will solve the error. Let's try to execute this particular function again. let's create sentences again and let's execute this particular function call again. Okay, so now we have got this particular chunks. Let's try to analyze this. Let's store it in a variable named chunks and then let's see the length of chunks. How many chunks we have got? Okay, so out of the paragraph, we have got total 3 semantic chunks. Let's see the first chunk, what exactly it is. So this is the very first chunk. It contains almost, it contains 3 sentences. Now why it contains 3 sentences? Because it found out that these 3 sentences are similar. And that is why these 3 sentences are a part of the first chunk. Now let's analyze the second chunk. Now here we have got only one single sentence in the second chunk because there might be some words or there might be some context that might not match with the previous sentence. And that is why the score was less. And because of which this particular sentence was not a part of the first chunk. Now let's analyze the third chunk. So here you can see we have got our third chunk. This contains multiple sentences and you can see in this particular chunk that almost every single sentence is similar. Even by reading, you can understand these sentences are directly attached with each other. Here, you can see every single chunk is not of the same size, even there is no overlap present, but still these chunks are acting as standalone chunks, and these are more powerful than the chunks that we have created from the previous methods. Now, this was a simple algorithm that we have used where we have checked the similarity between consecutive sentences. But we can apply some other logic. We can have couple of sentences together and then check the similarities between those couple of sentences. We can have similarity check between the paragraphs and so on. We can have multiple such ideas based on the use case that we are working on. So I hope the entire implementation of how we can create semantic chunks out of the text that is provided is clear to you all. I have tried my level best to explain this simple function. If you are still not clear, then I would recommend you to watch this particular section again. Your doubts will be cleared. So that was about the implementation of semantic chunking strategy. Now let's see when to use semantic chunking strategy. While processing the text where preserving the semantic integrity is crucial. I already have shown you an example where semantic chunking will suit the best whenever we have a paragraph or we have multiple text files in which fixed size chunks cannot be made, or maybe the chunks that can be made with the normal method won't work while the retrieval process. In that case, we can go for semantic chunking. When dealing with documents that have complex structures and topics. So I already said that semantic chunking is very much powerful. It can almost deal with all the documents that have complex and difficult structures as well as the content present inside it. For natural language processing tasks that require meaningful and contextually rich text segments. If you correctly implement the semantic chunking strategy as per your use case, then it will serve as the most useful chunking strategy for your use case. It will help you to retrieve the most relevant chunk to any particular given query, and which will obviously increase the results of the RAG pipeline. So I hope when to use the semantic chunking strategy is very much clear to you all. Now let's have a look at why to use semantic chunking strategy. First, for semantic integrity, it ensures that each chunk is meaningful and contextually appropriate. Only this type of chunking strategy will be useful to create meaningful and contextually appropriate chunks because here every chunks are created with the help of natural language processing technique and which is very powerful. Secondly, we use the semantic chunking strategy for improved NLP performance. It enhances the performance of downstream NLP tasks by providing coherent input. Semantic chunking strategy is also going to be used to preserve the context. It maintains the logical flow and context of the text. So I hope the usage of semantic chunking is very much clear to you all. Document specific chunking. First, we'll have a look at the official definition of document specific chunking. And the definition says that document specific chunking is a methodology of splitting the text based on the unique structure and content of the specific document. Now, we might have data of a particular format. You might have observed the JSON format. There are curly brackets and it contains key value pairs. This is one type of format. Then we have MD files, which are nothing but markdown files. Markdown files contains some particular format of text. There are headers, there are subheaders, there are some images which are formatted with some particular syntax. Also, there are certain links which are again formatted. One best example where we can apply this document specific chunking is nothing but code. Every single coding language has their own syntax. Let's take Python syntax. Let's take an example of Python code. Python code contains functions, classes, there might be some constructors, there might be some variables defined, there might be some libraries imported. For every single functionality, there is some syntax defined. So that is again one type of document which has a specific format. So when we have such types of documents, there we can use this particular chunking strategy, which will split the text based on the unique structure and content. So it makes the task easy. This particular approach customizes the chunking process to suit the organization format and context of the document, such as chapters in a book, sections in an article, or headings in a report. Obviously, here we cannot use the recursive character text splitting or normal character text splitting. Also, if we use semantic chunking here, it might not work correctly. So in this case, this document specific chunking suits the best. So I hope you might have got an overview of what exactly document specific chunking is. Now, let's have a look at the working of document specific chunking. Let's see that. So, first we analyze the document to identify the structural markers like headings. Let's take an example of empty files. Empty file contains some headers. Headers are defined by hash. If there is one single hash, it is parent header. If there are two hashes followed by text, it is counted as subheading of the parent header. Similarly, if the number of hashes increases, it is counted as child headings. So, for MD files, we analyze the document to identify the structural markers. So, here in this case, we have the structural markers as headings, that is hashes. Once we analyze it, we simply use these markers to define where chunks should start and end. So, basically, we'll make this as splitters. Based on the splitters, we'll split the text. We'll simply separate the text into chunks. This is how we can create the chunk and we can define where it should start and where it should end. Then we can simply extract the text between these markers to form chunks. And once chunks are created, we ensure that each chunk maintains the context provided by its section. Now, for doing such tasks, there are already a lot of inbuilt libraries present. Also, we can simply define our custom function to do this particular task. We can simply customize the functionality as per our need. So I hope the working is clear. Now let's simply have a look at the practical implementation of how this document specific chunking works. We'll see different examples of different document formats so that it will be clear to you what and when to use. Now let's see how we can implement document specific chunking. Now let's say we have this particular Python code. We use this particular code for creating semantic chunks. Now what we'll do is we'll simply create chunks of this particular code. Now, here in this particular case, we cannot use recursive character text splitting, or semantic chunking because by using that, it won't create correct chunks where the context will be preserved. Here, this particular thing is a Python code and Python has its own syntax. Now, we'll simply use LangChain library to create chunks out of this particular text. First, let's simply store this particular code in a variable called as py. Let's simply store it in the form of a doc string. Let's execute this. Now in LangChain, we have a library called as Python code text splitter. This particular library is inbuilt and it will automatically create chunks of Python code. So we'll simply import that particular module. So from LangChain dot text splitter, we'll simply import the Python code text splitter. Now let's run this. Now let's simply call this particular module Python code text splitter, and in this we'll simply define some parameters. So let's define the chunk size. Let's keep it as 100 and then define the chunk overlap. For now, I'm going to keep the chunk overlap as 0. Now these are the parameters that I have defined, and let's store this particular object in a variable called as PySplit. Let's execute this and we have our text splitter ready. Now we'll simply call the function named as create documents from this particular object that we have defined. So PySplit dot create documents. Now why we use this particular function? Because here we didn't have created the documents of it. We simply have a plain text. We don't have it in a format of document object. That is why we have used this particular create documents function. It will automatically convert each and every chunk in a document object. And if the text document contains any metadata, it will automatically store the metadata of it also. So we'll call this create documents function, and inside this we'll simply pass the variable py in which we have our code. Now we'll not simply pass this particular variable as it is, we'll pass it in the form of a list. Now I already have told you the reason why we pass it in the form of list. If you want to know the reason, then you can simply have a look at the earlier videos where I have explained you fixed size chunking as well as recursive chunking. And let's simply store this particular thing in a variable called as chunks. Let's execute this and our chunks will be ready. So let's see what exactly is present inside this variable chunks. Let's execute this and you can see we have our chunks ready. You can see every single chunk is now in the form of document object. Since we had no metadata in the plain text, we are not getting over here. You can see how it has created the chunks for our Python code. You can see all the libraries. You can see these libraries are separately stored in chunks. If you look at the function where we have defined the split para to sentences function, it has stored the entire function in a single document, or I would say in a single chunk. All the comments are separately stored. You can see even the conditions, the if condition, the else conditions are separately stored. But here I can see that where we have defined this particular list comprehension, I think it doesn't rectify it correctly because you can see this particular list comprehension, it should continue till this particular in sentences. You can see here we have this entire thing in one single list comprehension. It should store this entire thing in one single chunk, but it has not done that correctly. So for now, it's fine. LangChain might update this in future so that the list comprehension will be stored in a single chunk. Rest, I feel that every single chunk is properly created. So you can see how useful this particular Python code text splitter is. This is a type of chunking strategy for document specific chunking where we have a Python code. So I hope this particular type of chunking strategy for this specific format is clear to you all. So you can see here we have this particular first header, which is the parent header. When we see the preview of what exactly is the output of this particular file, then we have this image. Here you can see the image has got displayed. Now here this is a fake URL that I have generated. So that is why the image is not getting displayed over here. But if you write any genuine URL over here, it will simply display the image of it in the preview format. Then we have this normal text. Next we have this double hash header. You can see its size is smaller than the parent header, that is the one with single hash. Next we have the double hash header again. Next we have this particular image. After that we have this triple hash header. Here you can see the triple hash header size is lesser than the double hash header. Similarly, the text goes on. I hope you might have got an idea of what exactly MD files are and how we can use it. Now I have simply uploaded this particular blog.md file here in the collab notebook. We'll load this file and we'll create chunks out of it. Now for doing so, we'll again use LangChain text splitter. And specifically here we are going to use markdown header text splitter. So let's import that from LangChain dot text splitters, import markdown header text splitter. Now next we'll load the file and we'll read the content out of it and store it in a variable. So with open, inside this we'll simply write the name of the file, that is blog.md. We'll open it in read mode, we'll store it as file, and we'll simply read that particular file and we'll store the content out of it in a variable named as markdown text. Now we'll simply create an object of this particular module, markdown header text splitter. So let's do that. We'll define the splitter variable and we'll simply call the module markdown header text splitter. Inside this, we'll have to pass on the headers to split on. Now, headers to split on is nothing but a list. Now, this list contains tuples. Each tuple contains the header sign, that is, if it is 1 hash, if it is 2 hash, and the second part of the tuple contains the name of that particular header, say header 1, header 2. So let's define this particular headers to split on list. So as I said, it is a list and it contains tuples. Let's define the first tuple as hash for the header 1. Let's define the name of it as header 1. Similarly, we can define another tuple of double hash and we can simply write header 2. For now, I'll define only two tuples for two hashes, 1 hash and 2 hash. So what it will do is it will create chunks based on these splitters, double hash and single hash. Wherever it addresses any of these patterns, it will separate the text and it will form chunks out of it. So now let's pass on this variable as headers to split on and then simply define one more parameter, strip underscore headers, and we'll set it as false. So far we have defined these two parameters inside our markdown header text splitter, and let me correct this spelling. Yeah, so our object will now be ready. So let's execute this particular thing. So far we have defined our content in the variable markdown text and we also have set this particular splitter. Now it's time to create chunks out of it. So let's define the variable chunks. Inside this, we'll simply call this particular splitter object dot split text. Now inside this, we'll simply pass on the markdown text, the variable in which we have defined the content of the MD file. Now let's execute this particular cell and our chunks will be ready. Now just to show the output better, I'll be defining a loop here. For I, comma, chunk in enumerate the variable chunks. What this enumerate does, it will simply return two things. First, it will return the index of that particular element in the list that we have passed on here. And next is the content that we have defined in that particular list. And then inside this for loop, we'll simply print chunks in a particular format. So let's execute this. So here you can see we have got our chunks. Now let's make it better. Now over here you can see we have got the page content equal to. Why? Because every single chunk contains the page content. So we just want to access the page content parameter out of it. So let's define page content and let's execute this again. So now over here you can see our chunks has got created. This is our chunk 1. This particular chunk contains our first header, that is my travel block. Next we have our chunk 2. this contains the second chunk, which has a double hash header. Then we have chunk 3. Here you can see double hash header was addressed, and that is why these chunks were separated. Now here you can see in this particular chunk itself, we have one more header, but this time it has a 3 hash. So it has been a part of this Paris header only. Why? Because in this particular object, we have defined the headers to split on as 1 hash and 2 hash only. If you would have defined 3 hashes also, it would have created a new chunk for it, for this. Next, we have the chunk 4 with 2 hashes again, and then chunk 5 with 2 hashes again. So I hope context is clear to you all, how it splits the text based on the specific format. So because of this, better chunks are created, and if better chunks are created, obviously your RAG flow will be better and you will get more accurate results. So I hope the document specific chunking strategy implementation is clear to you all. We have seen how we can create chunks out of a specific formatted code of a particular syntax, as well as we also have seen how we can create chunks of markdown text, which has a particular syntax. Now that we have seen the implementation of document-specific chunking with multiple examples, let's summarize it into when to use this type of chunking strategy. So when dealing with documents that have a clear and distinct structure, the documents which have a particular format and the syntax remains universal. In that particular case, we can simply use this type of chunking strategy. When preserving the organizational format of the document is important. Yes, there might be cases where the document formats matters a lot. In that case, we can simply use this chunking strategy for tasks that requires contextually relevant chunks tailored to specific document types. Now, if you look at real world use cases, there we might have multiple types of data. And for sure, you will come across with such data where specific format has to be maintained to preserve the context and meaning. So there we can use this type of document specific chunking strategy. I hope this is clear. Now let's have a look at why to use this particular chunking strategy. So we can use it for custom fit. It tailors the chunking process to unique structure of the document. As I already told you that here in this particular type of document specific chunking, you can simply create your customized functionalities so that as per the data that you have, you can create your custom chunks. So here we have the accessibility to tailor the chunking process. Next, to preserve the context. It maintains the logical flow and the context of each section. As we already have seen in the MD files, each and every header was preserved as separate chunks. Next, for relevance purpose, it ensures that every single chunks are relevant and meaningful based on the document's organization. So for all such tasks, we simply use document-specific chunking. I recommend you to explore this more and solve multiple use cases based on this chunking strategy. It will be very helpful to you. Agentic chunking strategy. So let's have a look at what exactly this agentic chunking means. First, we'll see the official definition of agentic chunking. By the definition, agentic chunking is a text processing technique that employs large language models, that is nothing but LLMs, to decompose the textual content into clear, simple, and contextually independent propositions. Mark these words, it is a text processing technique, which basically makes the context more meaningful so that we can use that created propositions as chunks, or we can then perform any other type of chunking on it to create chunks. And note one thing that here it uses LLM itself to process those data and convert it into independent propositions. So this make this particular technique different from the other chunking strategies that we have seen before. These propositions that are created by using this particular technique, they are then used such as building blocks for various downstream applications like question answering, summarization, and information extraction. So this agentic chunking is not only one of the way to create chunks, it is also a way to handle these particular tasks like question answering, summarization, and information extraction. So I hope a basic idea of what exactly this agentic chunking means is clear to you all. Now let's have a look at the working of agentic chunking strategy. The LLM is used to identify and extract the propositions from the input text. Propositions are essentially declarative statements that convey information. So, as already discussed, LLM is used over here to create the propositions. And what exactly propositions are? They are nothing but they are individual, independent statements that convey complete information about the scenario. Don't worry, I'll take some examples through which this proposition concept will be clear to you all. And we'll also see how we can convert the raw data into these propositions using the agentic chunking technique. Now, once these propositions are created, then these refined propositions are grouped into chunks based on semantic similarity or other specified criteria. Now, one thing to note, this second step is optional and variable. Yes, you can use the propositions itself as chunks. Otherwise, you can go for the next step. You can create your custom chunks based out of that particular propositions based on any of the chunking strategy that we have seen before. You can use recursive character text splitting, you can use semantic similarity. The large language model can be used to determine the optimal chunk size and composition. You can use the LLM itself. You can ask the LLM also to create custom chunks out of this. The LLM will itself decide the chunk size and the composition of that particular chunks. So I hope the working of agentic chunking is clear to you all. This is how it works, and now we are going to see how we can implement agentic chunking using one of the most popular and best large language model. That is nothing but Llama 3. So let's see the implementation. Now for implementing agentic chunking strategy, we require a very important thing, that is large language model to create propositions. Here I'm specifically using Llama 3 70 billion instruct model. And obviously, if you are using large language model, you will have to frame a prompt. This prompt is nothing but set of instructions that we give to the large language model to perform a particular task. Here the entire game is in the hands of prompt. The way you write the prompt, the way you will get the results. Your prompt has to be very specific, concise, and understandable by the large language model. And yes, every large language model has its own template for writing prompt. If you want the prompt template of Llama 3, I'll post it in the description box. But for now, I'll simply explain you the template in the example itself. I hope these things are clear. Now we'll see the paragraph that we are going to work on. So this is our very first paragraph. Here, these are set of statements. You can see in a forest, a fast rabbit and a slow tortoise who were friends. Now this is the first sentence. Now the second sentence starts with they raised. Here the pronoun they is used. If you separate this sentence from the previous one, then it's difficult by the machine to identify to whom we are addressing. So this second statement is not a proposition. Here it is not independent statement through which we can get the idea about the completeness of the statement. Similarly, if you look at the last statement, the rabbit learned not to underestimate others and they stayed friends. Over here also we can see pronoun is used. They stayed friends. If this particular statement becomes independent from the previous statements, then we cannot understand to whom it is addressing. So these are not propositions. These are not independent statements. These are not complete statements. So agentic chunking strategy makes every single statement propositions. It will create each statement in such a way that it will become independent so that we can further use it to create chunks, or we can simply keep it as it is as separate chunks. So I hope this paragraph is clear. Now we'll have a look at the prompt that we are going to use in the large language model of Llama 3. And this is the prompt. So I'll quickly tell you what exactly is the significance of each and every statement here and what exactly is the template. So you can see the very first line here I have defined the header. Now this is a part of the prompt template of Llama 3. Here this conveys that the further set of statements that will be provided in the prompt is nothing but the system prompt. That is the set of instructions that we are going to the system, how it has to behave. You can see here it is written system. It says that the next lines are going to be system prompt. And what exactly is written? You are an agentic chunker. You will be provided with a content. So basically, we are providing the instructions to the language model, how it should behave. So I have highlighted these statements. What exactly it has to do? It has to decompose the content that is provided into clear and simple propositions. Now, since large language model is trained on humongous amount of data, it understands the significance of each and every word. So that is why I don't have to explain what exactly proposition is. I can simply write the word proposition and I can simply describe it in simple lines if required, ensuring that they are interpretable out of the context. Now, these are the steps it has to follow to convert each and every statement into proposition. First, it has to split the compound sentence into simple sentence. So wherever it addresses the compound sentence, I hope you know the compound sentence meaning, it has to convert it into simple sentence so that it can become independent to understand. And the large language model has to maintain the original phrasing from the input wherever possible. So this restricts the large language model to not respond with a huge variation in the data from the actual context that was provided. Second instruction we can give for any named entity that is accompanied by additional descriptive information, separate this information into its own distinct proposition. So here we are declaring what exactly it has to do. It has to convert every statement into separate distinct propositions so that it becomes independent. Decontextualize the proposition by adding necessary modifier to nouns or entire sentence and replacing the pronouns. This is very important. It has to replace the pronouns with the words that has to actually fit there for it to become independent statement. For example, it, he, she, they, this, that with the full name of the entities they refer to. Large language model is intelligent enough to understand to whom that particular pronoun is addressing to. It will automatically replace it. Fourth step that it has to follow is that present the result as a list of strings formatted as JSON. So here we have defined the output format, in which format it should output the response. It has to provide a list of strings formatted in JSON. Now you can see over here, our system instruction is complete. Next, we can see this particular header. Here it says, here it conveys that the system instruction is now over. Now comes the user part. Here comes the user prompt. So from this onwards, whichever statements will come, it will be user statements. It will be a part of user prompt. That means here we can provide the context on which it has to work on. We can provide the user query also, but here in this case, we do not require the user query. Here we only require the content that has to be converted into proposition. So here you can see we have given the content as a dynamic variable. So here we are going to replace this particular string by the paragraph that we have seen before. And then we have simply written the statement strictly follow the instructions provided and output in the desired format only. So that it will again understand that it has to follow the instructions that were provided earlier in the system prompt. Next, you can see we have written this particular line. This is a part of prompt template. Here it says that the user instructions are now over. Now the user prompt is over. Now it's your duty to further generate the answer. So here you can see the assistant keyword is written. This assistant keyword says that now onwards, the LLM has to generate based on the instructions provided. So this is nothing but the prompt that we have written, and we are going to pass this particular prompt in the Llama 3 model so that it will convert the paragraph that we are going to pass in this particular prompt into proposition. So let's have a look at it. So I hope this particular prompt is clear. If you have any doubts, you can post it in the comment section. Now we'll pass this prompt in the Llama 3 model. So here you can see we have declared the variable content. Inside this, we have fed the paragraph that we have seen before. Then we have initialized the variable prompt. Here you can see the same prompt that I have shown you before. I have put this in this particular variable. Now from this prompt, you can see this particular string, curly bracket content. Here we are going to replace the content with the actual content paragraph that is stored in the variable content. And we are going to store that into the actual prompt variable itself. And then we are going to pass the prompt in the function LLM. Inside this function, what exactly is done? Here, the Llama 3 model is called, and this particular prompt is fed in the Llama 3 model with appropriate parameters like temperature, top P, top K, then max new tokens, and so on. If you want to know more about the parameters that Llama 3 takes, you can check the documentation present on the Hugging Face website, or if you want it, you can just comment it. I'll post it in the comment section itself. And once this particular cell is executed, you can see this particular generated text. This generated text tells that the LLM has provided this particular generation out of the prompt that was passed. You can see as per the instruction, it has provided list of statements in JSON format. Over here, you can see the first statement. There was a fast rabbit in a forest. The rabbit had a friend who was a slow tortoise in the forest. You can see every single statement is broken down into propositions, an independent statement, so that if another person comes and read any of any of the sentence, that person will understand what exactly is happening inside that particular statement. It will be a simple as well as a complete sentence. Then I shown you the last line. The rabbit learned not to underestimate others and they stayed friends. Let's see this last line. The experience taught the rabbit not to underestimate others, and the next sentence after the race, the rabbit and the tortoise remain friends. So here it becomes complete sentence. This is done by the agentic chunking strategy that we have seen now. This entire thing of passing the prompt in a large language model and telling it to convert this into propositions is nothing but agentic chunking strategy. Now you can use these individual statements as individual chunk. Otherwise, you can apply the semantic chunking strategy on top of this to create chunks out of it. I would suggest you to apply semantic chunking strategy on top of this set of statements so that your result will be much better. So I hope this example is clear. Similarly, I would like to show you one more example where I have applied agentic chunking strategy. The prompt remains the same, only I have changed the example. You can see this is the paragraph. Here it discusses about the outlier. You can pause the video and have a look at these statements. We are now going to pass this paragraph into the prompt, and we are going to send that prompt into the large language model. And we are going to use the same prompt that we earlier discussed. Now let's have a look at the code. Here you can see the content is now about the outlier. The prompt remains the same. We have replaced the content string with the actual content, and then we have passed this prompt into the LLM function. And here is the output. You can see the output is a list of string, and each string inside the list is a proposition. It's a complete statement. You can pause the video and have a look at the output clearly. And as I said, you can further apply the semantic chunking strategy on top of this. So I hope this particular example is also clear, and I'm damn sure now that agentic chunking strategy must be clear to you all. I have tried my best to explain you how to write prompts and how to format the output also. Here I used Llama 3 model. You can use any of the large language model, but make sure you write the prompt clearly and properly. Now let's summarize what all we have seen in this particular video by looking at some points when to use this agentic chunking strategy. First, in question answering, breaking down the complex text into propositions can facilitate the identification of relevant information to answer the questions. Yes, of course, in any of the use case, you can use this agentic chunking strategy to make the information more relevant to read as well as to understand, especially in terms of question answering tasks. In summarization case, also you can use this. It will create the concise summaries by selecting and combining the informative propositions. Similarly, we can use this agentic chunking strategy in information extraction. extracting the information from text by focusing on relevant propositions. I would like to suggest you to explore this because it is very powerful strategy. You can use it in almost every single task to make your flow better. Also, you can use it in text classification to categorize the text based on the presence or absence of the specific propositions. Now, I hope when to use this strategy is clear to you all. Now we'll see why to use this type of chunking strategy. Focus on the first point. It improves the understanding. LLMs can capture the underlying meaning of the text, leading to more accurate and informative chunks. And yes, in some cases, if your actual data is difficult to understand by humans, then if you use this strategy, LLM can make it better to understand. It will correct it and it will make it simple to answer it from the data also. Next, this strategy is flexible. It is known for its flexibility. The chunking process can be adapted to different downstream tasks and requirements. We already have discussed what all tasks we can perform using this particular chunking strategy. This is very much flexible. Next, it is known for its efficiency. By focusing on propositions, agentic chunking can reduce the amount of redundant information from the chunks. So if your actual data contains repetitive statements, which might create confusion in the rest of the flow in the rack system, this particular chunking strategy will also reduce the amount of redundant information. It will only keep the meaningful and important information only. And by this, the entire rack flow will become efficient. And with this, we come to the end of the video. I hope the agentic chunking strategy is clear to you all. I have almost covered every single thing related to this. If you guys have any doubt, then you can straight away put it in the comment section. I'll be very much happy to solve it. And yeah, for funny memes, but at the same time, technical and corporate memes, you can simply follow me on my Instagram page. The link is in the description box. For more such videos, do like, share, and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.